Hey gang, and welcome to the Worksheet Solutions Walkthrough for IUPAC Nomenclature, Take 2, Functional Groups Galore. So if you're here, I'm assuming that you have done the IUPAC systematic naming. You've watched the video, you've looked at that first worksheet, maybe you looked at the video walkthrough for that worksheet. Now, I'm assuming you're here because you're looking to take your naming game to the next level. You're looking to break free of just alkanes and maybe some halogens, some halides, right? So in this video, if you're here, maybe you've looked at the worksheet, we're throwing in all types of functional groups. We're talking alcohols, we're talking ketones, we're talking everything under the sun. It's all fair game. So the tricky stuff, in my opinion, with this, naming, IUPAC fashion with functional groups beyond just alkanes and halides is that you need to worry about priority. And I like to think that the problems I pick expose some different scenarios you can run into, but enough of me talking. Clearly you're here for answers and, more importantly, explanation to those answers, so let's get started. Okay gang, so luckily everything we've learned thus far still applies. There's really just one more thing we're kind of layering on top of our knowledge of IUPAC systematic naming, and it's that we will have multiple, or we have the possibility to have multiple different functional groups in our structures. So linked with, I look over at my laptop, linked to the video on jOeCHEM along with this worksheet and the answers, there's a priority functional group list I've added. It's what I've consulted the IUPAC table. I just wanted to make my own. But you look, given your structure, if you see multiple different types of functional groups, you consult that table, you see which functional group has the highest priority, and when you go to find your longest parent chain, you need to include the highest priority functional group in that parent chain. So for example, if your parent chain is going to be a little bit shorter, to include that functional group, you need to do that. So you need the longest parent chain with your highest priority functional group in the molecule. So enough of me yapping, let's see this in an example. Okay, so in the first letter on problem 1 on this worksheet, we have this structure. So if we see, alkanes and halides, they are at the bottom of the barrel. We're barely going to consider them, hardly. Here, we really have two things to consider. We have the alcohol and we have this ketone. And if you look at the priority list, ketone takes the cake. So we need our longest parent chain, and we need to include this ketone, and also ideally we want to give it the lowest number possible. Okay, so I'm going to start counting from up here and going this way. So we could do, I'll start right here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bingo. That's our longest chain. And we're going from here down because that gives the ketone the lowest number. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now that we've identified the parent chain, it's business as usual. Just name your substituents. If you have to use parentheses, don't be afraid to bust those bad boys, bad girls back out again, and then alphabetize, do the name. So if we look at 3, 1, 2, 3, looks like we have 3 propyl. Let me put this up there just in case someone's jumping around the video. 3 propyl, and then 4 looks pretty complicated, so we will be naming that in parentheses, so let's hang on to 4. Weirdly, 5 we are also going to need to name in parentheses, but it's much simpler, so I'm going to use a different color for that. Let's do green there, and then that's it. So let's do 5 and then we'll do 4. Both not that bad. So let's look at 5. So 5, we will open up our parenthesis, and the nice part is that our chain is just 1. So we have a bromine on 1, a bromo on 1. So we could do 1 bromo methyl, or you can just do, so you could do 1 bromo methyl, 1 bromo methyl. This is totally valid. No problem with that at all. Or, since you only have 1 carbon, if you just want to be kind of an organic cool cat, you can just do 1 bromomethyl, because you know that the chain only has, the substituent has 1 carbon, and off of that 1 carbon you have a bromine. So 5, and then you can either do 1 bromomethyl or just bromomethyl, up to you. It won't change the alphabet, the alphabetization or anything like that, okay? Also, I'm pretty sure that's a word, I'm sticking with it. So, now we can do 4. So, parent chain, right, we're gonna start here with 1, and then 2, 3, and 4. So, we have 2, 2, and when you have OHs as substituents, not as your parent chain, they are labeled as hydroxy groups. So you can do 2, 2, and since we have 2 of them, it's going to be dihydroxy. Those are our only substituents within our parentheses branch, and then it's butyl, so dihydroxy, 2,2-dihydroxybutyl. Make sure that is what I have. That is in fact what I have. So now we just need to actually stick our name together. This is a no name, but it's not just going to be a no name, and we will see how we indicate where the ketone is. So, and again, just for this first one, I'm gonna write the name out, but then I'll do the thing where I pause the video, write the name. But remember, for alphabet purposes, this counts for alphabetization, this counts, and this counts because of parentheses here, as well as there. So we have 5 bromo methyl hyphen, and then we have the 4, 2, 2 dihydroxy butyl. Sorry if I end up misspelling something. That's on accident if you catch that. And then we have the 3 propyl. And I'm gonna, just so I have some more space, propyl. And then it's going to be nonan hyphen. So you don't end it with the A-N-E because that means alkane, but this is not, that's not our parent. This is a ketone overall. So non-an, and then you say where this functional group is, and then you consult the functional priority list chart to see what the ending is. And for ketones, that's O-N-E. So this is basically saying, we have this bromomethyl at 5, the dihydroxybutyl at 4, the propyl at 3, and we have a 9-carbon chain, and at 2 we have a ketone. That's how you would read this name, okay? So now that we've done one, we've got our feet wet a little bit, I'm gonna, again, we'll plow through the rest of them. I'll pause the video. You won't have to see me, struggle with writing the name, and we'll just plow through this worksheet. Okay, gang, so in the second example of this worksheet, we have this structure. Now, one of the things you'll see if you look at the functional priority group list is the carboxylic acid reigns supreme. So right off the bat, we see a carboxylic acid in our structure. When you see that, that's an automatic, this is where you're starting your parent chain. This is going to be 1. So when you get a carboxylic acid, it's almost nice, it saves some brain power, you know exactly where you're starting, and then from there you're going to number and find the longest chain. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And again, that would also be 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have a few ties, and we need to figure out where the branching will help us break this tie and determine our parent chain. So 1, 2, 3, 4, 5. So 5 is kind of our forking point. So we know we have 8 down here. However, it's kind of out of the running because right up here in branch 6, right, we have branching, but we do not have branching at this position 6. So this down here, not going to be the parent chain. So then up here we have 7 and 8. However, this route loses because at 7 here we have branching, whereas at 7 there we do not have branching. So 7 and 8. So I like this problem because even though we know exactly where our parent chain is going to start, we have 3 different routes all tied for 8 for the longest parent chain. Okay, so now that we've determined our parent chain, we just go through the process. Name our substituents, alphabetize, produce the name. So at position 4, so we haven't really come across amines as substituents, but if you check the functional group priority list chart, right, not only does it show you which group has priority, but it shows you how to name functional groups like amines and alcohols and ketones and aldehydes as substituents themselves when they are not the highest priority group. So at 4 we have amino. That's how you would name amines as substituents. At 6, we have an ethyl. At 4, we have, or sorry, at 7, we have a methyl. And then interestingly, at 5, we have something we need to name in parentheses. So let's draw some parentheses around this. So again, we start off with the first carbon attached to the parent chain being 1, then 2, and then 3. So as you can see, nothing too complicated here. We are parenthesis pros by now. So if we open this up, we just have 2 hydroxy, and then we have 3 total carbons. So it's 5-2-hydroxypropyl. No big deal. That's nothing we can't handle. Let me just make sure that's exactly what I have in the name. Yep. So we have a parent chain of 8, so it's going to be octan, but remember, it's not going to be octane. It's going to be just octan, and then I will show you how to, name a carboxylic acid. But real quick, we have A, E, M, and H. So obviously A is going to come in first, and then we're going to have the E in ethyl, then we have the H in hydroxy, and last but not least, we have the methyl right there. That's the order. So give me a second, I'll write the name, we'll talk it through, and then move on. Okay gang, so like you'd expect it to be, we start off with the 4 amino, 6 ethyl, 5, and then parentheses, 2 hydroxypropyl, and then 7 methyl, run it all together, and then carboxylic acids, if you consult the functional group priority list, have an oic space acid ending. And if you're wondering, hey Joe, why isn't it octan 1 oic acid? Now, you could write it that way. However, it's redundant because a carboxylic acid has to be on the end of a chain. It has to be terminal. So, if it's terminal and it's the highest priority functional group, and we're going to start our chain there, the 1 is redundant. You don't need to include that because if someone looks at this name, they know exactly, okay, this is a carboxylic acid, the parent chain is 1, that's where the carboxylic acid is because it has to be on the end of a chain because you can't have a carboxylic acid in the middle of a chain. So don't put the 1, it's redundant, save yourself the finger strength. Okay, next example. Okay gang, third problem on this worksheet. So if we take a gander at the structure right here, maybe the first thing you're thinking of is, okay, I see we have 2 types of functional groups here, right? We have the alkene part and we have the alkyne part. Now, intuitively, you think alkenes are higher priority than alkanes, 1 extra bond. You're absolutely right. On that logic, you think, oh, alkynes, 1 more bond than alkenes, higher priority, right? No. If you actually look at the functional group priority list, it's one of the things I think some people get mixed up. Alkenes are actually higher than alkynes. So it goes double bond, triple bond, single bond. So if we take a look at this, it can be, disastrous for you naming this problem if you don't realize that the alkenes are kind of calling the shots here. So both of these double bonds need to be in our parent chain, and in including both of them in the parent chain, we need to get the longest one there. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're gonna go this route. Now, do we go left to right or right to left? And it's gonna be left to right because 1, 2, and you kind of assign the position of an alkene based on the first carbon in the bond. So 1, 2, 3, 4, 5, 6. So we have 2 and 6 versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 and 6 versus 6 and 11, or whatever those 2 numbers were, that will dictate the parent chain going left to right. So our parent chain looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 to round it out. Okay, so now that we've found the parent chain, we've understood that alkenes trump alkynes in terms of priority, we just have to follow the process. Name our substituents, produce the name. So, if you can see on 8, 8 looks like something we know, because we really have 2 branches. We have a branch on 5 and we have a branch on 8. 8 looks warm, fuzzy, and familiar. That is just our good friend isopropyl. So common name yet again coming into the fold. 5 looks like we need to name it in parentheses, right? So if we do 5, open up some parentheses, I'll even draw it like this. So nothing changes. Carbon right off the parent chain gets a 1. Then we can either go 1 and 2 or 1, 2, 3. And its longest chain here is the propyl. So we have 2 methyls on 1. So our name in parentheses is 5,2,2 dimethyl propyl. So we've named our substituents. Now, actually writing the name is going to be kind of fun and interesting. I'm actually not going to stop the video. So for alphabetization, we have this and this. So first and second. So we actually have the 5,2,2 dimethyl propyl hyphen 8 isopropyl. Again, sorry, excuse some misspellings if I do them on accident. Okay, so now at this point, and I'm going to do something here if anyone knows a little bit more about alkenes at this point. So we need to remember, alkenes are going to be at the very end. They're dictating the name of our overall structure, which is a dodecan derivative. So we actually indicate where our alkyne is by doing 9yn, like, so 5,2,2 dimethylpropyl, 8 isopropyl, 9-ine, and then we actually do our alkenes. So then we can do, one second, just make sure, yep. Oh, whoops, I actually did that, I apologize. So we actually start to write, so we do dodecan, then we do 9yn, and then we do, so this is part of the parent name, but it doesn't finish the name. The highest priority does. So then it's 2, 6, 2 and 6, and then we do diene. So I apologize. So you list your substituents, and then when you have alkynes and alkenes, if you have both of them, you write the parent name, and then you write kind of up to where you would finish the name. You indicate where the alkynes are, and then you finish the name with the alkenes. And because we have 2 of them, we do a di. Now, for those who, if this is included earlier in their organic chemistry course, or if you're coming back to this after knowing more about alkenes at the end of OChem 1, if you look at these alkenes right here, there's more information you can provide about them. If we kind of draw a line about these alkenes, we could have more substituents off of them, but we don't. You can see if I walk the alkene, I cross the dotted line that I have in both scenarios. So you can have E or Z double bonds. If this is extra information, just ignore it. If you walk the line and you're on the same side, then it's a Z double bond. But if it's not, then it's an E double bond. These are German words. I forget what they mean in German or what the actual German words are. Z means on the same side, E not on the same side, which is the case here. So actually, don't be confused if you see this name on the worksheet solution written like this. That just means these double bonds at 2 and 6, make sure you draw them, and they're, in this situation, they're trans. But I could have had a substituent like this, and then that would have changed everything. E and Z terminology is the global terminology. So, more on that in the future. But this is the name, this is optional. I'd be very happy if you know how to do this. This would be exceptional. Okay, next example. Okay gang, problem 4, 2 more. Okay, so in this problem, I really like this because we're about to see something that you may never have seen or done before. So if we take this in, I think by now, after a couple glances at the functional group priority list, you're thinking to yourself, okay, even though I see those cute looking alcohols, So cute. The ketone reigns supreme here. So the ketone is calling the shots. Now this creates a unique situation for us because the ketone is a part of this ring. Now, it may have been easier maybe to have this chain and then have the ring as a substituent or something like that. In the past, we've always had rings as substituents, but because this ketone is the highest priority functional group, the ring must be our parent chain, which means this is unfortunately one substituent. So we will have to name this in parentheses, and what you'll even see is we'll have to do parentheses inside of parentheses. And if you didn't think that's possible, guess what? It is, and we're about to do it. So, since this is a ring, and the ketone's our highest priority group, we can give it a 1. Now, we have the luxury of we have to make the decision of going left or right. So we want to go the way that provides the lowest amount of numbers, like numbering of our substituents. So we can either do 1, 2, 3, 4, 5, or 2, 3, 4. So clearly we'll do 1 and then go clockwise, 2, 3, 4, and 5. So very easily we can say it too, we have a hydroxy. That is certainly a cakewalk to write down as opposed to what we need to do for the substituent on 4. So we have a giant set of parentheses right here. So again, it sounds scary, but it's really not that bad. There's just a process, and we have to follow the process, and then by the time we know it, what seemed like a monumental task is already over. So on 4, we have to do the longest chain. Obviously our chain starts here at 1, that's attached to our ring, the parent chain. 1, 2, 3, now we have a choice. We can either do 3, 4, 5, or 3, 4, 5, and 6. So we should go that way, 4, 5, and 6. Longest chain. Now, we can very easily, so let's open this up. I'm gonna give myself some room, so I'm gonna start writing it here. So at 4, in parentheses, we have 4, I'm actually going to go ahead and really quickly write down here, do 4-methyl, because we'll have to alphabetize these. 4-methyl, we have 5-hydroxy, and funny enough, wouldn't you know it, at 3, I don't know a common name for that, so we actually need to, in a fun different color, name that in parentheses, and what we can do is our parent chain is 1, 2, so within our parentheses, at position 3, I'm going to open up more parentheses. We have a 1 chloro, 1 methyl, ethyl. And you can see I kind of did some alphabetizing on my own, right? Because we do have chloro and methyl on the same carbon, but obviously C comes before M. So 1 chloro, 1 methyl, 2 carbons total, ethyl. So that takes care of the parentheses inside of the parentheses. So funny enough, we actually need to put this name together just for this parenthetical beast, if you will. So to actually alphabetize this properly inside of 4, let me just make sure, okay, this is looking good. So what we need to do is, since there's parentheses here, right, this matters, and then this matters. Well, these parentheses specifically. So I'm actually giving myself some more room to write this down. It's going to be 4, and then 3, 1 chloro, 1 methyl, ethyl. Then I can close that. Yeah, that makes sense because we're inside. These are, sorry, I'm getting lost in parenthetical purgatory. And then we can do a hyphen. And then we can do 5-hydroxy. And then we can do 4-methyl. And then, now that we've taken care of everything, we had a 6 chain right there. That's hexyl. And then that ends our bigger set of parentheses. So just to recap, right? We have 6 carbons in this substituent. We very easily named the hydroxy and the methyl, but we had to name this in parentheses right here, and that ended up being 1-chloro, 1-methyl ethyl. So to alphabetize, this came first, then this second, then this third, and then we tacked on the hexyl. So to write this name, right, which seems like a distant memory because we went down that rabbit hole, for alphabetizing, we have the H, and then we have the C, right, because we're in parentheses, so the very first thing that comes is that. So I'm going to cheat and just use this, so then this just becomes, I'm going to erase this, and I'll continue to do this, well, I'll do this in blue, then 2, and then I'll bring it down here, hydroxy, and then remember our parent chain is this ring, so it's cyclopentane, right, because it's cyclopentane, and then you can go ahead and do the 1-one, right, O-N-E because of the ketone, or it is commonly accepted that if you have a ring, and say for example you have a ketone, everyone will understand that you made the ketone the first position in the ring, so you can have the cyclopentane 1-one, or you can just have cyclopentanone. Up to you. Either is valid, it's totally cool. So this was a bit of a bear, but I wanted to show you some of the hard naming problems so that no matter what someone throws at you, you can name it with ease. Okay, one more, just stick with me. Okay gang, I don't know about you, I'm full on naming, so let's do this last example and put naming away for a little bit. Alright, so if we take in this wonderful structure, I hope you're seeing, okay, we've seen the ketone a few times, been high enough priority to pretty much, command, highest priority of, to be in the parent chain, to dictate what's happening. However, we see a new functional group, and it's the CN. Now, if you've looked at the functional group priority list, this is a nitrile, and the nitriles are higher priority than ketones. So for once, the ketone is taking the back seat, the nitrile's in the driver's seat, this is a substituent, and this needs to be in our parent chain. Now, nitriles can be sneaky, and even I did this when I was coming up with the problem. When I looked at the, when I was generating the name, just to double check myself, I had it wrong, and that's because, look at nitrile. There's a carbon in this functional group. So don't think about counting here, or here, or here. Just like carboxylic acids, it's weird because we actually draw the C in the nitrile. They are terminal. So our chain starts here at the nitrile. This carbon, that's carbon number 1. And from there, we're going to find our longest chain. That includes this nitrile. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, yeah, so it's the 7, right? 2, 3, 4, 5, 6, and 7. So we have I've been meaning to do this, but we have heptane derivative, okay? So let's name some substituents. So with 2, right, you're probably thinking to yourself, Joe, please no more parentheses, but don't worry, 2, with our common naming knowledge, that is just sec-butyl, so I would say, don't worry, no parentheses. However, you're probably looking at 4 thinking, come on, Joe, really? Last time, I promise. Okay, so at 4, and it's so much simpler than what we just did, no parentheses in parentheses. We have this ring, so if you, right, the process is to properly include this fluorine in here. We got 1, 2, and 3. It doesn't matter if we did 1, 2, or 3. The fluorine is always going to be 3. So at 4, we have 3 fluoro, and then run it together because that's the only substituent in our parentheses. I forgot to do this. So 3 fluoro cyclo. Oh my gosh, I'm blanking. I can't remember. Butyl. Jeez, oh man, I'm so sorry. just had one of those moments where you pretty much just forget everything about everything. So 3 fluorocyclobutyl just all runs together. And weirdly enough, right, we need to consult the functional group priority list, but it's not to see who's going to, it's not to see, who's commanding the parent chain. It's to actually name a ketone as a substituent, and you do that by oxo. So 6-oxo, super short, nice and sweet. So we've named our substituents. We know our parent chain name. So to put it all together, right, we don't count the sec, it's not in parentheses, the F counts here, the O counts here. So we got 2-sec-butyl, then -4, whoops, 3-fluorocyclobutyl, and then 6-oxo, and then we got teptan. We can do 1-nitrile. Again, the 1's redundant, but it's weird to have 2 N's in a row, so I like it that way. Okay, gang, so I hope if maybe you were thinking to yourself after IUPAC naming, you're thinking, okay, it's easy. Like, the practice was a breeze. Come on, Joe, where's the challenge? I hope this was maybe the challenge you were looking for. Again, I don't think anyone will give you ridiculous problems like these. In my experience, you get the ridiculous problems before the test, and then in a timed environment, you get something much simpler just to actually evaluate if you know how to find the parent chain, break maybe ties between the longest parent chain as far as like branching at lower numbers and stuff like that. If you can do this, I'm confident you can name virtually anything. And esters and amides are left out because they are named in a much different fashion that comes in OCHEM 2. So if you're wondering why those were included in this video, that's why. If you're watching this video, that means you've thrown me a bit of money and you've supported jOeCHEM, and I can't thank you enough for doing that. And I hope you're getting the value out of these worksheet explanation videos. Thank you for letting me be a part of your organic journey. I'm happy to be here. I hope that I'm here now, and I'm here whenever you're done with organic chemistry. No matter what, I hope to see you all in the next video.